Good morning, everyone. Again, my name is Brahanu, and
This is Brad Zacabe from Cool IT Systems.
thanks. We're going to go over the other topic, which is liquid-to-liquid CDU test methodology and performance rating. There are a lot of contributors on this work. Brad and I are just here to present this effort. So. I'm going to go over just the high-level overview of a CDU. There are a lot of CDU vendors and vendors of ingredients that go into the CDU. So we expect this wide range of audience here. So high-level overview, and then Brad will have a deeper dive on the test methodology. The CDU being the brain and heartbeat of the entire secondary flow network that connects the facility side to the IT side of the flow network, and all the thinking and acting, all that monitoring, telemetry, all that is within the CDU. So there are a lot of contributions on all the other ingredients in the secondary flow network, but the CDU is relatively least where we have contribution at OCP. So this is just to start that conversation, and going forward, we'll have more work on the CDU side to bring the ecosystem to where we need it to be. There are two types of in-rack and in-row CDU. The application and the capability and all that is different. So just the general overview, typical design and construction considerations to go over, to go through the critical components of the CDU, the heat exchanger. Again, the main focus being the fluid part has been discussed with the fluid team, and all the ingredients going into there you go. Okay. Yeah, for some reason. All the ingredients going into that CDU need to be compatible with the fluid, as has been discussed, and other considerations also when we're selecting these materials, not just materials, even some of the critical components like the pumps, the filtration systems, the control valves, seals, just specific to this particular application, some of the areas need to be considered. There are documentation for most of those, and we're going to combine all that and focus on what are the design and test methodologies of a CDU. Details of this is in the document, but we'll have a deeper dive just in focus of the test methodology, which Brad gonna go over.
All right. Yeah, so as Berhanu said, there's going to be a lot more detail in the document that's being released in November. This is just going to be like a high-level overview of what we would suggest that CDU manufacturers do, or that people who are looking to buy CDUs are going to be asking from the CDU manufacturers to perform and present to them. So Keegan did a great job, I think, talking about a lot of the testing that needs to be done. For the fluid side, we'll talk about that a little bit, but just making sure that you have all of your components selected, that the materials are compatible with the fluid, and if you need to, consult with your fluid provider and do additional testing if necessary. Performance testing, so we have a few different components of CDU performance that are kind of pretty standard that need to be considered. You have your thermal performance, which we look at approach temperature difference, where we're measuring the difference between the technical coolant system and the facility water system. Some of us like to call that secondary and primary, but we'll stick with that for now. So that's the thermal performance. That's highly related to the heat exchanger that's in the CDU, of course. On the flow side, there's two sides to it, the technical cooling side and the facility water side. And so it's one side is the facility water impedance, and the other side is the technical water pumping. And we'll go into a little bit more detail on that. Power consumption is a big thing that we want to look for in a CDU. Again, one of the benefits of liquid to liquid is reduced power consumption for the CDU and reduced power consumption for the data center overall. The control system functionality, making sure that it's behaving the way that you expect it to. When certain conditions become a reality, how will it react? And then the serviceability aspects of it. Rack versus row-based, you may have different field replaceable units, different access points to the CDU, and making sure that that is being well considered. In addition to that, durability, reliability. Shipping and storage was something that was discussed previously as well about, freeze point. How does the CDU manage that? Is it able to contain the fluid? Is it going to be able to be shipped full, depending on what type of fluid you choose? Is there going to be any kind of corrosion in a humid environment if it's being shipped by a boat? Those types of things. And then, of course, shock and vibe. Pressure vessel as well. So these CDUs, they're not high pressure necessarily. I think a lot of the cases were below 100 psi on that. But making sure that it can withstand the pressure that's going to be inside the system, that every component of that network is capable. Especially on the secondary side, it's typically less than 100 psi. On the primary side or the facility water side, it could be even higher. And making sure that your seals and all of your components are going to be able to withstand and not bulge or deform. Redundancy verification, again, this goes back a little bit to the control system, but a lot of CDUs have N+1 or N+N redundant components, pumps, sensors, so making sure that switchover is seamless and that you don't have any downtime with the CDU with the redundant components. Fluid and material compatibility, so again, back to Keegan on that. We had the component level testing, coupons, but then at the same time, you probably need to make sure that all the components that are in the system together are behaving as they should be when they're mixed together and all touching the fluid at the same time. Highly accelerated life testing as well. We look at doing things in thermal chambers or with halt chambers, shock and vibe, thermal shock, those types of things. And then on the regulatory side, we're starting to get a little bit of alignment across the industry on what the regulatory requirements for CDUs should be, since it was a bit of a new product category when we all started this thing. So that's on the safety side, electrical as well, typical data center requirements for the equipment that will live inside the racks or beside the racks, and then your typical kind of material compliance components as well. So one other thing that we wanted to kind of highlight as well is just the way that we're presenting the data for performance specifically, to make sure that when we're sharing it amongst the industry as a CDU provider or as someone who's ingesting that information, that it's consistent and that it's in a format that's going to be useful. And so firstly, talking about the thermal performance, so on the approach temperature difference, what we want to see is on the x-axis, your heat load in kilowatts, on the y-axis, your approach temperature delta, and making sure that we have kind of one curve for each fluid that may be tested, a flow rate, that could be a secondary flow rate, a primary flow rate, or a combination of both, or temperature, because all of those factors do impact the approach temperature difference, and this is not a 2D problem. There are many factors that come into play here. So some CDU manufacturers might put one or two plots on, but there's certainly a lot more that could be generated. And so if you're looking into CDUs, make sure you're considering that and asking for the data at the right data points. And so like I said, you have to specify the type of fluid that's being used in the test, what temperature that fluid's at, what the flow rates are for both the facility and the technical side, and then again, the fluid type of the technical water. On the flow side, we have the technical cooling side of things. That's the pumping side. So we look at the kind of pump head on the y-axis, typical kind of PQ curve, but in this case it is a pressure head curve. So you have your flow rate on the x, pump head on the y. We propose some kind of typical units of measure to use in those cases. And again, you need to specify what fluid you're using, what temperature it's at, and then also something to just make sure is clarified in those data presentations as well is where is that DP being measured? Does it include QDs? Does it not include QDs? Is it the pump itself inside the CDU? We'll make sure that's very clear. And then specifying the fluid and temperature combination. On the facility side, it is an impedance curve, so it's more of that kind of polynomial in the typical fashion. X-axis being flow rate again, liters per minute, y-axis being differential pressure as an impedance, so a pressure loss across the primary side. Again, you need to specify what fluid you're using, what temperature it's at, and again, measuring where you're measuring that with QDs, without, or otherwise. And then the last piece here, second to last piece, I guess. This is something that I think we need to standardize as well. I would say that, in general, some of the CDU manufacturers, including CoolIT, have not been super aligned on how we, specify or state what the performance or the rated performance of our CDU is. And so I think this is just the first step of trying to get this really fleshed out and agreed upon. But we kind of have a proposal around how we should rate performance for CDUs. This is a capacity rating for how much heat load a CDU can cool. And so we're proposing a couple standard operating conditions, and then understanding for that rating what certain things need to be met. So the standard operating conditions are going to be, we're proposing, are that the facility fluid would be water, and that the facility fluid temperature would be 40 degrees C, which is your kind of ASHRAE TC 9.9 water class W40. We chose 40 C because it's a common kind of upper limit. There are obviously higher classes, but they're not that common. And so we're not trying to push the envelope too much on that. And on the technical cooling side of things, PG25 as kind of your most standard single phase direct liquid cooling CDU fluid. So for the in-rack CDUs, those are the smaller systems that sit inside the rack that would cool mostly just the IT that's inside the rack. We're proposing that the rating should be X kilowatts, where the CDU performance meets the following conditions. Technical side, DP pressure head should be greater than or equal to 25 psi at X, which is again a kilowatt number, times 1.5 liters per minute. So 1.5 liter per minute per kilowatt as kind of your standard target flow rate. And so again, at that flow rate, your pressure head should be at least 25 psi. On the facility water side of it, the impedance, similar idea, 1.5 liters per minute per kilowatt with the water, and we would like to see that impedance be less than or equal to 75 psi. And really what you're trying to do is figure out at what heat load are you reaching that 5 degrees C approach temperature difference, which is a very common target as well for the industry, with those two criteria being met. Again, at those 1.5 liter per minute per kilowatt flow rates with the PG25 in the water. Very similarly, on the in-row CDU, the only difference being how much pressure head the technical side with the pump should be capable of producing, because it has to flow through a little bit more manifolding, maybe a few more connections to get to where it needs to go. So we're proposing that at that 1.5 liter per minute per kilowatt flow rate, we should be seeing over 40 psi for that performance rating to kind of be applicable. Everything else about that is the same, where we're looking at the 5 degrees C approach temperature difference at that flow rate with water and PG, and seeing the facility side be impedance be less than 75 psi. So that's a good starting point for everybody. I think the other thing that we want to note is that there are ways to, go above and beyond that. This is just kind of a way to make sure that we're all on the same page in terms of performance when we're talking about it. There's a lot of ways to say, our performance could be more, but the approach temperature would be more, or something like that. Of course, this is kind of just a plot showing, how we can modulate and improve upon design systems. So creating kind of a capacity matrix could be a next step. So using higher performance cold plates, for example, can enable lower system flow rates. We used 1.5 liter per minute per kilowatt as kind of a standard starting point, but some cold plates don't need that much flow rate. Some might need more. And so, understanding the impact of that on the system is important. And then for the approach temperature delta, you may be able to either accept a larger approach temperature delta by your system design. Maybe you don't have such strict requirements on the facility side, or maybe you can design your CDU to achieve an even lower approach temperature delta at a specific flow rate. And so showing that in a bit of a matrix format is also a good idea. So that's it for now. I think next steps and call to action. So we have the paper that's coming out. We're going to continue to work on the work stream and try to get kind of agreement and sign off and maybe specify that performance rating standardization.